Right. So today's lesson is about velocity of the rocket system. So in this lesson, we are going to derive an equation for the velocity of rocket system. A rocket is an example for variable mass, and in the lower classes from 10th to intermediate or plus 2, we studied that a rocket works on the principle of Newton's third law, action equals to minus reaction. When rocket is launched by igniting the fuel with an initial velocity, it is an example of projectile, and the fuel inside the rocket chamber is burnt and amount of gases are released, and these gases are ejected out through the nozzle tail of the rocket. If it is considered as an action, then motion of the rocket against the gravity towards the vertical direction up is the reaction. So as the rocket is going up, when it is going up, its velocity increases. When its velocity is increased at any time, given time, we have to find out the velocity. What's the velocity of the rocket in terms of mass of the rocket at present, and then acceleration due to gravity. So as I said, rocket is the best example of variable mass system. Variable mass system means a mass which can be varied with respect to time. So when the system mass is changed, decreased, here we are decreasing. It means mass of the system is decreased. It means an amount of the mass is ejected out from the system. It is considered as negative. So we are going to derive the velocity of the rocket at any time, at the given time. So we are going to derive that one. So this is our topic today. For that, we have to consider uh, the rocket system. So a rocket, so this is head of the rocket here, and this is the chamber. And these are the wings of the rocket. And next here we have a nozzle tail here. Nozzle means we have small holes. This is the nozzle entrance at the tail. And at this entrance here, so the gases which are released during the combustion of the fuel, and they come out ejected out from this or through this nozzle entrance here. So this is the rough diagram of a rocket here. Initially, mass of the rocket here. So initial mass, we calculate that one here. Initial mass. So this equals to, we denote with mass m naught. I'll put a naught, m naught. So this is the mass of the system when it is yet to be launched in the lab, including with the body of the rocket, the fuel, and the material which is used to burn the fuel, the total mass. The total initial mass of the system is mu naught. So then it is launched with an initial velocity. So we have to consider the initial velocity also here. So initial velocity, I'll put again V naught. So this velocity must be equal to or greater than escape velocity, because every object on the surface of the earth is influenced by the gravity of the earth, and due to the gravitational force, it could not escape the gravity of the earth. So to escape from the gravity and enter into the space, an object must possess a minimum velocity which is equals to 11.2 kilometers per second, that is escape velocity. So this is the initial velocity which is equals to or greater than escape velocity V0. And then later, what happens? So this rocket is launched and it is moving in upward direction. So the rocket is moving in upward direction. So this is the motion of the rocket here. So it is moving in upward direction, means it is moving against to the gravity. Against to the gravity. So the acceleration due to gravity is considered as negative. G is the acceleration due to gravity and it is considered as negative. And then after some time, so due to the combustion of the fuel, so large amount of gases are released here. So all the gases, they come out through the nozzle. So when they come out through the nozzle, these gases are coming like this. So this is the amount of the gas which is coming through the nozzle here. So this is known as jet, the amount of the gas that we call as jet. So this mass, this is equals to, we denote with m. I'll put a capital letter here. This is the mass which is coming out through the nozzle in the form of gases here. And its velocity of the jet. So the velocity of the jet is here. So we have to note down in opposite direction to the direction of the rocket system. So this velocity is u. As it is in opposite direction, this jet is coming here in this direction. So this is the direction of the jet here. So this is the mass and this is the velocity u, and which is negative. And this rocket, it is moving here with the velocity v. This is the velocity v after some time. After some time means after some time t seconds. This is the velocity here. It is in upward direction. And we have the weight of the rocket system. Weight of the rocket system here we have which is upward direction here. This is weight of the rocket system. And this is equals to mg. But this rocket is moving upward and acceleration due to gravity, this is considered as negative. So I will put a negative sign to weight of the mass. So this is weight of the system, rocket system. This equals to minus mg. And then here, so to find out the velocity at any time t, we have to consider again here the external force. How much force is acting on this rocket system, total system. System means the rocket which is moving upward, which is with the velocity v, and the jet which is coming downward with the velocity u. U is considered as negative with respect to v, as both are in opposite directions. And then this is the action, that is the ejecting of the jet, downwards is the action, and motion of the rocket is reaction. Action equals to minus reaction. And to find out the external force on acting on that one. So we have to calculate the external force here. So I will calculate external force, which is equals to MA. So this external force, which is equals to, this is M A. A is the acceleration of the rocket system. So I will write this one as, this is equals to M dV by dt. But M is not constant. Mass, it is a variable mass. So we have to differentiate that one also. So we will take that one inside d by dt of mv. So this is the total force acting on that one. So total force F equals to here d by dt of mv. So both should be differentiated in UV formula, U into dV by dt plus V into du by dt. So now I'm going to differentiate that one. So M first is the constant, and we differentiate V dV by dt. And plus V is constant and dm by dt. So this is differentiated as per the rule UV method in differentiation. So I will note down this as equation 1. This is the equation 1 here. So then next, coming to it's the same force in terms of mass, that is weight of the rocket system. So I will take here same external force, which is equals to, here we have weight of the rocket, which is in upward direction minus mg, and gas, that is the jet, is coming down. So the gas, the jet applies a pressure force, which is called thrust, T-H-U-R-S-T, thrust, plus weight of the rocket. So this is here equals to thrust applied on the system, which is equals to V minus U, that is the relative velocity, and multiplied by dm by dt. So this is the thrust applied on the system, and plus W. W is a mg value, but this is here we consider as a negative value because it is moving upward. This is mg here. If you write like this, then this is F equals to V minus U dm by dt, and then this is minus mg. So I will note down this as equation 2. Both the equations 1 and 2 are same. So I will equate the equation 1 and equation 2 here. So when I equate these two equations here, so first I will take equation 1 on left hand side. So on left hand side you have m dv by dt plus v dm by dt. So this is the left hand side equation, and this is equals to right hand side, this is the equation 2. This is V minus U dm by dt. This is the thrust acting on that one. And again here we have minus mg. Here. So this is what we have that one. Then I will divide the whole equation with m, or I will take this m to right hand side. This is the m here. We have this m. This m is taken to the right hand side. Then it will be dm by dt divided by m. So I will take that one now here. So now I'll take the same formula here. So m is taken that side, means here remaining term is dv by dt plus here we have I'm sorry, here we have to expand this one. So before taking that one, I will expand this one here, right hand side. So this is m dv by dt plus v dm by dt equals to, and expand the right hand side equation, v into dm by dt minus, so you have the minus sign here, u into dm by dt, u dm by dt, and minus mg. So here we have two similar terms here. So one is here v dm by dt on left hand side and v dm by dt on right hand side are cancelled here, and the remaining terms are written as it is here. So I will write the remaining terms here. So this is remaining terms are m dv by dt. So this is the left hand side term, which is equals to, on right hand side we have two terms, minus u dm by dt. So I'll put it in the brackets here. And the next term is minus mg. Now we take this m value here to the right side. So this m value is taken to the right side, and you will have here dv by dt is left over here, which is equals to minus u, and m is taken to the right hand side, so this is u by m, and multiplied by dm by dt minus already m in the numerator divided by m dv. Sorry, this is g. This one. So these two terms m and this m will be cancelled. So you will have the remaining terms in the equations here. Left hand side dv by dt, which is equals to minus u by m. This is the first term multiplied by dm by dt. Here we have the small letter m, but this is actually capital letter M. And the next term is, as the m is cancelled here, we have only g. So next step, here we have dt on left side. dt is taken to right side. Then it is dv equals to, this is minus u by m multiplied by dm by dt and multiplied by dt. Next term is minus g multiplied by dt. Again here dt is cancelled in the first term of the right side. So this dt is cancelled and you will have dv on left side. So this is dv equals to right side you will have minus u by m and multiplied by dm and minus gt. So this is the equation what you have in the differential form. Now to calculate the velocity of the rocket system, here we have to integrate this system from the initial value to that instant value. So let at the time t the mass equals to m and velocity equals to v. The initial values are here we have m naught mass and the initial value of velocity is v naught. And the time, for the time also here we have to integrate here with respect to v on left hand side and here with respect to m on right hand side. Actually this is gt. So this is gt here. So I have to write down that one. Here this will be right hand side is dv equals to minus u by m into dm minus g dt, that is. So when you integrate left hand side term we have dv, we have to integrate with respect to v, and right hand side with respect to m, the first term, and second term with respect to t. Within the limits we have to integrate that one. So the limits will be here we have to note down for velocity v0 to v. So the limits will be from v0 to v. I'll note down the limits also here. So the limits for integrations are, so we have to note down for that one. So velocity, for velocity from v0 to v. So velocity will be from v0 to v. Next, mass should be integrated from m0. Who is writing that? From m0 to m. This one. And time is 0 to t. So time value is 0 to t. So when you integrate that one, so here if you integrate dv, you will get v. So this will be here v left hand side, and the limits will be here we have from v0 to v. So that will be here v minus v0 after integrating you will have, and this equals to, you have minus u in the numerator. So minus u is constant here, 1 by m is integrated, then you will have log m, and the limits are here initial value m naught and final value m. So m divided by m naught you will have, and then minus g. G is the acceleration due to gravity, and dt is integrated you will have t. So t initial value is 0 and the instant final value is t, so you will get t as it is, t minus g. So after applying the limits you will have this one. So the final value here we have, this is V minus V0 equals to minus U log, this is base E, this is capital letter M by M naught minus gt. And then we want the velocity at the time t, so v equals to, here v naught is taken to right hand side, so v naught plus, sorry, this will be minus u log m by m naught, and then this is last term minus gt. Here m naught is the initial mass, m is the mass at the time t. As the rocket is a variable mass system and the amount of the mass is reduced, so m is less than m naught. So m is less than m naught. So we have to take down to the numerator, then that will be v equals to v naught plus log, I will take m naught to the numerator by m minus gt. So this is the required equation for velocity of the system of the rocket. Okay, so this equation, from this equation we can substitute the given values and then we can find out the velocity of the system